Alright, let's start this lesson off on invertible functions. So, let's go to the next slide. What is an invertible function? It's a function that has one y value for every x value. I'm sure you know from many math classes that a function itself, a normal function, is something that can pass the vertical line test. So something like this has one x value for every y value, but something like this does not, because it would have 2 points here. And that's what this is saying, is that when a function, you take the inverse of it, you're looking for something that only has one value, one y value for every x value. Some functions are not invertible. How do we find the inverse function? You essentially switch the x and y in a function and then resolve for y, and that will give you the inverse. Here's one way to evaluate it with a flow diagram. If you have variables a, b, and c for the inputs, they go to different outputs, 1, 2, and 3. You notice that each input goes to a unique output. Then that means for the inverse of it, each output, which is now the input, goes to one unique output. Now here's a function that is not invertible. You see, if you look over here, we have two values, two x values that go to the same y value on the output. If we try to do the inverse of this, you'll see it goes to two locations just because we just swapped it back and forth. Now this would mean that this, the inverse of this does not pass the vertical line test, meaning it is not a function, even though h itself was a function. Alright, let's take a look at families of invertible functions. We have linear, which is just lines. There's only one case that's not invertible, and that would be a horizontal line, because all the y values are the same. There's logarithmic functions, and those are invertible. Exponential functions, which you see these two, the two examples shown here are invertible because they both would pass the vertical line test, but in the case of a normal exponential, this could be represented as x squared. On the other side, if this was the y-axis, this edge here, it would look the same over here. And if you try to take the inverse of this function, it would not be invertible. So like x squared would not be invertible, but it is a family of invertible functions. A power function, we showed some of it. You see this would not be invertible because, like I showed over here, it has two two x values, two y values are at different x values here, so it wouldn't pass. If it doesn't pass the horizontal line test here, then the inverse would not pass the vertical line test to be a function. This is because there's no point where we can find two values across the same line. This one is not because there's 2 points at pretty much every location that the function exists. Same for this one over here. Also, trigonometric functions. These are repeating periodic functions, so it should go without saying that since they'll constantly repeat themselves over and over again, there's many, many times that it will fail the horizontal line test. Let's look at some examples of this, how we solve it. Alright, the function f of x equals 5x plus 4 divided by 3 is defined for all real numbers. If it exists, find the inverse of the function. Okay, so let's swap the values, or swap the input and the output, so that we would end up with x equals 5 we'll put y and replace that for f of x plus 4 over 3. And essentially we're just solving for y at this point. So we would end up with 5y equals 3x minus 4. And if we solve for y, we get y equals 3x minus 4 over 5. And this is also equivalent to f negative 1 of x, which is a notation for representing the inverse of the original function. The inverse of y equals 2 to the x is y log blank of x. Well, I wrote the one of the rules of logs over here. So y equals log bx is by to the x. So we know that this itself, not the inverse, but the actual function itself, is equivalent to x equals log 2 to the y. You'll see they've written here, if this is the normal function, if this is equivalent to this right here, then we need to swap the y values and the x values to find the inverse. This is just to verify that that is the inverse. You would get log 2 x. So we know that the answer here will be 2. If it exists, find the inverse of the function f of x equals 10x minus 2x over 3. Alright, let's swap the x, let's assume this is y and swap the values. So we would get x equals 10 minus 2y over 3. And then we'll solve for it. So we would get 2y over 3, 2y over 3 equals 10 minus x. We'll multiply them both sides by 3/2, and you get y equals 30 minus 3x over 2, and you stop writing diagonally, which, as we'd written before, this would be equivalent to f negative 1x, which is the inverse. We'll move down to a word problem. A small pizza shop owner decided to base the price of her pizza, her cheese-only pies, on the area of the pizza, plus a small fee for the fixed costs, such as the box. She came up with the formula PD equals 0.1 d squared plus 0.6, where P of D is the price in dollars of the pie, a pie of the diameter d inches. Find the inverse function, one that would calculate the diameter of the pizza from the price. Then use the formula to calculate or find the diameter to the nearest inch of a pizza that costs 15 inches. So I'm just going to represent this with P equals 0.1 d squared plus 6, 0.6. And we're essentially solving for d and using that as a function. It would be d a function of p. So we have p, the price, minus the 0.6 fixed cost equals 0.1 d squared. Divide it all by 0.1. P minus 0.6 over 0.1 equals d squared. And then we'll take the square root of it. And we know that this can be plus or minus. Now, any form of this, the positive version and the negative version are both in itself, they're each invertible functions, and represent a unique function themselves. But together they would not pass the vertical line test if we could represent that with a single function. So we got this here, equals D. So we're asked, what's the diameter of the pizza if it costs $15? And I'll plug that into my calculator. We only need the positive version because the diameter can only be positive in the real world. So the square root of 15 minus 0.6 divided by 0.1. And the answer is 12. Just your standard 12-inch pizza. It's not too bad. Kind of pricey for a 12-inch pizza though. But I'll let it slide. Find the inverse function g of x, f of x, the inverse function g of x of the function f of x below algebraically. Okay, so we'll swap the values and then represent it as g of x. So we have x equals -3 over, we know that now we're looking for g of x here, -4. So we end up with -3 over g of x equals x plus 4. We'll swap the sides of these two, and we would end up with -3 over x plus 4 equals g of x. And this would be the inverse of f of x. This is just some pretty basic examples for the concept of invertible functions, what is and is not invertible, and some of the problems, how you solve them. Alright, I'll see you next time for the next lesson.